Hello friends, welcome again. In this lecture, we will see more examples of row echelon form. In the previous lecture, we have seen that what is rank of matrix and how to find rank of matrix. We know that to find rank of matrix, we will convert the given matrix into two forms, which are row echelon form and normal form. In the previous lecture, we have seen that what is row echelon form and how to convert the given matrix into row echelon form. I repeat once again the definition of row echelon form. A matrix A is equal to Aij is said to be in row echelon form if all the first non-zero rows, if any, precede the zero rows. The number of zeros preceding the first non-zero element in a row is less than the number of such zeros in succeeding or next rows. And the first non-zero element in each row is equal to 1. But it is not necessary that the first non-zero element in each row is equal to 1. The other element will also work here. Now let us see examples of row echelon form. Here we have A is equal to 1, 2, 3, 2, 2, 3, 5, 1, 1, 3, 4, 5. We have to make these elements to be 0. So by performing R2 minus 2R1 and R3 minus R1, we can get these elements to be 0. So by R2 minus 2R1, R3 minus R1, we get A is similar to first row as it is second row. Now we perform R2 minus 2R1, that is 2 minus 2 is 0. Next 3 minus 4 is minus 1. 5 minus 6 is minus 1. And 1 minus 4 is minus 3. Next R3 minus R1, 1 minus 1 is 0. 3 minus 2 is 1. 4 minus 3 is 1. And 5 minus 2 is 3. Now, by performing either R2 plus R3 or R3 plus R2, we can get either R2 is equal to 0 or R3 is equal to 0. So, we perform R2 plus R3. Then you get A is similar to 1, 2, 3, 2, 0, minus 1 plus 1 is 0, minus 1 plus 1 is 0, minus 3 plus 3 is 0, in third row as it is. Now I interchange the second and third row, that is R2, R3. A is similar to first row as it is, third row, and here we write second row. Now let us check whether this matrix is in row echelon form or not. Here in A, we have all the first non-zero rows precede the zero row. Then the number of zeros preceding the first non-zero element in second row is less than the number of zeros in third row. Therefore, this matrix satisfies all the conditions of definition of row echelon form. Therefore, this matrix is in row echelon form and number of zeros in this matrix is 2. Therefore, rank of matrix is 2. Let us see another example. get these elements to be 0. So by performing R2 plus 2R1, R3 plus 3R1 and R4 plus 5R1, we get A is similar to first row as it is. Next, we perform R2 plus 2R1, that is 2 plus minus 2, which is 2 minus 2, therefore 0. Next, minus 5 plus 4 is minus 1. 1 plus 6 is 7 and 2 plus 4 is 6. Now we perform R3 plus 3R1. 3 plus minus 3 means 3 minus 3, which is 0. Minus 8 plus 6, which is minus 2. Then 5 plus 9 is 14. And 2 plus 6 is 8. Now 5 plus minus 5 is 0. Here we perform R4 plus 5R1. Minus 12 plus 10 is minus 2. Then minus 1 plus 15 is 14. And 6 plus 10 is 16. Now we have to make these elements to be 0. So by performing R3 minus 2R2 and R4 minus 2R2, we can get these elements to be 0. So by performing R3 minus 2R2 and R4 minus 2R2, we get A is similar to first row as it is, second row as it is, 0, minus 2 minus minus 2, which is minus 2 plus 2 is 0. Here we perform R3 minus 2R2. 14 minus 14 is 0 and 8 minus 12 is minus 4. Again we perform R4 minus 2R2. Here first element is 0. Minus 2 minus minus 2 is minus 2 plus 2, which is 0. 14 minus 14 is 0 and 16 minus 12 is 4. Now here either we can perform R3 plus R4 or R4 plus R3. So we perform R4 plus R3. Then we get A is similar to minus 1, 2, 3, 2, 0, minus 1, 7, 6, 0, 0, 0, minus 4, 0, 0, 0. Here we perform R4 plus R3, therefore 4 plus minus 4, which is 4 minus 4, therefore 0. Now let us check whether this matrix is in row echelon form or not. How to check? So here in A, we see that all the first non-zero rows precede the zero row. The number of zeros preceding the first non-zero element in second, third and fourth row, which are 1, 3 and 4, which are in ascending order. Therefore, this matrix is in row echelon form and number of non-zero rows in matrix is equal to 3. Therefore, rank of matrix is 3. lecture we will see the another method to find the rank of matrix, which is normal form. Thank you.